How does Wartsila India strategically integrate renewable energy solutions to maximize energy efficiency while ensuring seamless operation and reliability?
So the base load plants are which are running for our energy needs. The focus is more on renewables, adding renewables more into the system. So when we are adding more solar and wind into the system, that brings up the challenges of response times which are in terms of milliseconds and in terms of minutes. So these solutions need to be integrated with flexible modular balancing solutions, and that flexible modular balancing solutions are an important element on this renewable journey which we have to do. Today, maybe the cost of, as we know, 15 years back, the solar cells used to be costly. Over the time, they have now become more affordable, and now we see it more. Same is the situations on battery storage and also on the gas. The prices of the gas will stabilize over the period of time. That's what we are hoping. And also new solutions like batteries would come into. And when we are talking about grid scale solutions, it needs to be also looked at economic feasibility and dimensions. So combining these two together with also an important life cycle aspect, which I indicated, we need to also manage energy management systems in a best way so that we are able to forecast what solutions need to be used when, and then run in that way that we are able to get the best efficiency out of the plants and also on the portfolio, which will bring also to the cheap solutions on the energy. That would be my take on that. Yeah.
Thank you so much, sir. It is quite understandable, and you made it very easy to understand the things like. Now, I just would like to ask Mr. Subrata, in balancing renewable and fossil fuel energy for efficient grid management, what innovative strategies do you recommend to optimize resource utilization and ensure grid stability?
2 points I have mentioned. One is, of course, weather forecasting. Weather forecasting will play a very important role in this for improving efficiency of conventional power plants, and also just to see how much solar power can be generated. So we should depend more on IMD, that's meteorological department, and they should give us a true picture also. This is point number one. One number two is I put emphasis upon decentralized power generation from biomass, local biomass, whatever it is. Throughout the country, it's agricultural country, so there will be a lot of agricultural waste available. So that should be used for power generation, and these two combined can meet the requirement, and this could be the solution in future.
Thank you so much for discussing this. And I'll come to Mr. Baldev Raj Narang. The question for you is, how does Clariant Power System prioritize power quality criteria and enable smooth integration while maintaining grid stability in the face of large-scale renewable power induction?
So you're talking of power quality, which I also touched during my discussion. When we are adding these renewable plants, as I said, the conventional plants have no power quality issues as regards the harmonic circle. Harmonics is a major power quality issue today because they are continuous stray currents or unwanted currents flowing into the system. And the conventional systems like the transmission, distribution, not distribution, transmission, generation, as well as what we have the conventional systems available with us. Distribution also, only the utilization is the place where we get the power quality issues. But generation, transmission, and distribution, they were the clean processes. But as we move from fossil fuels, from the conventional plants to the renewable plants, the power quality issues have come to the fore. These plants are not very clean plants. They generate power quality issues, they generate harmonics, and they generate very difficult harmonics, not the conventional harmonics, and they need special solutions. The conventional solutions do not work here. And that is what we have to do it. The solutions are available, and they were not in place. Even the reactive power, which was a major requirement, was not in place. Nobody was asking these people to have a reactive power support. The power quality support, luckily, it has come in time before these plants are maybe getting momentum and the capacity is increasing. Already the CA has mandated that we should have the power quality norms compliance mandatory. And that is why what we have the STATCOMs, they can mitigate up to maybe normally 13th harmonics. What we are giving as a Clariant Power System, we have a STATCOM where it can mitigate up to maybe 23rd harmonic also. But that is again a limit. We have harmonics up to the level of 49th. And there the solutions, we have 5th, 7th, 11th, all those lower order as well. But those things can be taken care by the STATCOM or by the conventional passive LC filters also. But when we come to the difficult harmonics, there we have the special solutions. There a third element comes into picture in the passive system. The one we normally use LC systems, the detuned filters. But here we have another resistive element coming into picture, which is connected in a way that it bypasses all the higher order harmonics through it. It is damping is done through the resistor only. And these resistors are one of the major, you can say, component of these high pass filters. They are cost wise as well as the volume wise and the other importance wise also. They are the maximum, you can say, difficult items available. And we have luckily some sources available in India. And we get from overseas also these resistors. But as I said in my discussion, these high pass filters are in the initial stages. The solutions are available maybe for last many years. People have been using them. But in the conventional, in the load generated harmonics, they were not very critical. They were not normally required. But in renewables, it is a must. And we have to develop those capabilities. And maybe, again, we simulate these things on PSCAD and we put the values and we find out what type of filters will be able to deliver the results. And then first we simulate on the programs, on the systems, software, and then we actually put it in the field and we see whether there are any deviations or not. And certain deviations can be corrected by tuning the inverters or by maybe doing some adjustments in the turbines, also wind turbines. So that is how we have to address these issues as we go along. And they are already, these people have done it in Australia, in Africa. We have been quoting these systems to those countries also. And they are a part and parcel of the renewable plants. But in India, it is just started and it is the right time, in fact. And we'll be able to manage these problems also.
Thank you so much, sir, for this valuable insights. So whatever we discussed just now, the topic is very, we can do many innovative things in that, and there is a much chance to elaborate more. So I would like to ask you a comment.
Comment on future innovation techniques and also this balancing between the two. Yes, the same points I need to repeat again. 2 points which are highlighted. One is of course meteorological dependence on meteorological data, and biomass should come in a very big way. I will give you some example why biomass is so important and coal is not. Coal is of course a dirty fuel. We do not want to touch it. Coal is being discarded out. But biomass, it is a very small power plant. Maximum capacity could be 25 megawatt. And they are very good for a small investors. You can get easily loan. Small land is required. It doesn't require very big land. If water is available, then it is good. If water is not available, then also by air-cooled condenser, it can generate power. There is no issue. And the cost is also very less. So very small investors can go through it. So it is a very attractive solution to the investors. Local biomass, whatever is a local biomass. And in North India, which we have been working, that has reduced the stubble burning. That is, reduces stubble burning sizably. Previously, farmer has to burn the parali on the land itself, and that is to create a lot of pollution, not only in Punjab, Haryana, in Delhi also. So now there is a slightly reducing trend because now they can sell the product. Farmers can sell the product. There is a commercial benefit. So I strongly recommend local biomass, whatever is available, non-bagasse biomass that should be used at a large scale in a decentralized way, and that will offer you a very flexible power. Very, very flexible power. You can reduce, you can increase, whatever you want, you can do. No problem. So that can be a good substitute of coal. That is my submission is.
Actually, we have some questions for you here pending in the inbox. So before coming to Mr. Baldev with the next question, I would love to ask Mr. Venkatesh. The question is for Wartsila. So the question is from Sujoy Kumar Roy, and he's asking that if we add solar or BESS or other renewable sources, are the IEE 2800 guidelines also focused on? Apart from that, how subharmonic part can be addressed? I understand conventional PP usually are designed not to have harmonic distortions.
The IEEE standard, as Subrata mentioned, it is for interconnection and interoperability of inverter-based resources, interconnecting associated transmission electric power systems. These BESS systems have inverters, and these inverters are designed accordingly and equipped with harmonic filters so that they address these grid regulations. So also the international standards followed on this, and there are harmonic studies conducted for each and every site or the location where we are going to put up that solution. Based upon that grid and that location, we also then mention that harmonics related studies, and then inverters are picked up and selected. So very important question, and that's an important aspect which we need to address also while going towards selection of those solutions. Yeah.
The next question from the audience is for you, sir, and that is, what are the common causes and effects of poor power quality on electrical equipments, and what measures can be taken to mitigate these issues?
Power quality, the issues, they are basically conventional power quality issues, what we are talking. Let us take aside now, he is talking of the equipments. So this power quality issues, harmonics particularly, they are generated by the loads only. And the loads, they generate the harmonics because we have today non-linear loads. Maybe about a decade or two back, we used to have majority of the loads were linear. Maybe about 70% loads were linear, and only maybe 20-30% were non-linear loads, and the harmonic generations was very nominal, and there were no issues as such. That was not difficult to be absorbed by the maybe systems, the loads as well as the grid. And as and when now, because the non-linearity is increasing, the harmonic generation has increased, and these harmonics are being created by the loads only. And these loads, when they create these harmonics, they flow towards the source. They suppose the load is there on the PCC, the harmonic currents will flow back towards the grid. They will encounter various buses, the transformers, and they will ultimately land up in the grid only. So when at each bus level, they get converted into voltage distortions, which we call voltage harmonics. And these voltage harmonics, they come back to all the loads further. So the situation becomes more and more complex. And what is happening is, if these harmonics are not checked, they will create nuisance for loads itself, the consumers, as well as the grid also. The problems are many. There could be nuisance trippings, because these are harmonic currents basically, and these currents, they operate the some protections like thermal protections. They sense the loads, harmonic currents as the normal currents, over currents, and they operate the thing. That there are nuisance trippings because of that. Then we have the additional heatings. The losses are there. the heatings, they distort the performance of the system, the controls as well as the normal performance of the item. Because all the items, they are generate, all the controls, they are designed for 50 hertz. And when we have these harmonic currents at 250, 350, 750 and all flowing along with the normal current, the performance is distorted. So we don't get the desirable result, the desirable performance from these systems. So there are issues in that, and the failures are there. And there are two things. One is that these harmonics, they are generated by the loads, but they are getting amplified by the capacitors. The capacitors, they don't generate harmonic. We use capacitors for power factor improvement. Today, the capacitors, because all the utilities, they are now shifting to kVAH billing. The power factor is very important. Everybody wants to maintain unity power factor. And these capacitors are being used indiscriminately without any checks and all. And they are amplifying these harmonics further. And what is happening is the capacitor is amplifying the harmonics, and the capacitor itself is failing in the process, because it is the, you can say, culprit as well as the sufferer. So that the first item which fails in an harmonic environment is capacitor itself. So whenever we see the mass scale failure or the failures of these capacitors, we can assume that the harmonics are there in the system. And when these harmonics go back, now there are IEEE 519 guidelines. So these harmonics have to be controlled within those levels. Normally, most of the people fall in the category of maybe 8% THD. Now, one is that there are two things. One is THD levels are there. So we have to maintain these levels within, say, around 8%. The harmonic generation could be 20%, 30%, or maybe 12% or anything, but they get amplified and then they are sensed by the grid. So there we have to see that we are within that IEEE 519 norms. So for that, we have to have those harmonic filters. We have to have active or passive filters and all. So these harmonics, when they go back to the grid, and the grid, they are not able to, you can say, control them, because the regulations, they are still not in place. Except for maybe a couple of utilities, nobody has put the norms. Nobody has put the penalties or the systems in place that even the tariff structures can take care of these things. Some of the tariff structures are being designed so that if the harmonics are there, you will have to pay a higher bill. So that way, these things are yet to take shape. Except for Tamil Nadu, no utility came out with the measures, stringent measures to check the harmonic levels. So even the kVAH billing, it is not fully foolproof. They are allowing the overcompensation, and overcompensation is again a problem, and that is going unchecked. So the norms, the regulatory commissions, the utilities, the CA, all this, CA has already made the norms, but it is a state subject, so they cannot implement. It has to be implemented by the states only, which are not going forward at the pace it is required. And power quality is something where people don't invest, because it doesn't have the return on investment like in energy efficiency. So what is happening is these things, unless they are made mandatory, unless there are norms available, unless they are enforced, power quality will remain an issue, and it will everybody, including the consumer himself as well as the utilities, and those consumers who are not generating the harmonics, they also suffer, because the voltage harmonics come back to them as well. So what we need is the very stringent regulation for controlling this thing. All the tariff structures have to be designed in such a way that the harmonics are being controlled. There have to be incentives, there have to be penalties. Otherwise, nobody does it. In energy efficiency, people do it because they get the ROI. And we have a lot of promotion going on for that. But for harmonics, for power quality, there is no such incentive. There is no such, you can say, incentive or penalty. So this is missing in the system, and that is creating a problem. And everybody is suffering because of that. Power quality today is a very big issue. Just like in renewable, the CA has mandated. People cannot get away with it. They have to put the harmonic filters. But in the industries, in the commercial sector, or maybe all the normal conventional loads, it is still free for all. People are just managing with that, and they keep on having failures, and they continue to do that.
Next and the last question from the audience, and it will be go to Mr. Subrata Das. So I just would like to ask you the challenges and opportunities in integrating renewable energy sources with the existing thermal power plant infrastructure, like challenges, benefits, managements, and opportunities.
It's now very clear that it is mandated this renewable energy will go up and coal-based power plants will come down. And that is final. And at the same time, the solar or wind cannot go alone. It has to depend on somebody else, some conventional power. So that conventional power, whom the solar has to be dependent upon, that is coming down. Means coal plants are coming down. So there should be a substitute. There's substitute emphasis on biomass power. Biomass power can act as coal power. It is for the purpose of grid management, it is same. But at the same time, it is very environment friendly also. It is flexible, it can vary its load, no issue. From 40% to 100%, no issue. It can be done. So this is one of the solution which I can see very well. And next point, I once again repeat, I have repeated 3-4 times, the forecasting of solar generation and to be given to the conventional power plants so that they can plan accordingly for best efficiency. If they have to run at 40% load, then what is the best efficiency? They should calculate from the software. From the software will tell it, you run at this way, you get the best efficiency at 40%. You cannot go theoretically more than this. That point should come up from their inbuilt software. So, and that they should follow. That will give their best efficiency. These 2 points I want to tell.
I just would like to proceed further with the closing statement that I would like to start from Mr. Venkatesh. As we have many questions with us, but as we are time bounded, so we'll just come to the conclusion and it will be starting from you, sir.
Thank you, team, for the very good session which we have done now. So as we see it, the energy transition is an important journey which we have embarked upon now. The energy ecosystem is changing with more renewables coming into picture. And when renewables are coming into picture, that's a very good direction which we are going towards sustainability. But when we are doing that, there comes up also a lot of issues and challenges which we need to address on the way. And that is very important, as many of my co-panelists also indicated, need to have different solutions in place. Those solutions need to be coupled with also policies in place, which will help us to build also that directions. So as we said, as Subrata ji was mentioning, if we are talking about renewables and the forecasting, how could it then be a balanced approach which we can take on using the different solutions which we have to build up on the direction towards net zero? So to bring the net zero to that direction, we need good forecasting techniques, different solutions in place, which we then can, orchestrate depending upon which hour of the day, what solutions need to be used. That would bring us also towards the best economic models which we can look forward to. So this is a very important journey which we have taken upon, and this need to continue in the next 2-3 years, planning and implementing. That would then help us also the decade-long journey which we would embark upon towards building up a foundation stone and the direction towards energy transition for our future.
Now I just come to Mr. Baldev, just a little conclusion on this and your thought on this thing.
Just conclude on this thing. We touched upon this battery energy storage systems. So this is something I'll close by talking something about this aspect. This is a very important point. Like maybe suppose you have a 100 megawatt plant, you need about 120 MVH system, the battery storage system for that. And this is something which will solve many problems. The continuity, because solar and wind, they are not continuous generating plants. They depend upon the weather and the conditions. And when we have the battery energy storage, we solve many problems. We maintain the continuity, and this is solving the other issues as I discussed in the beginning, like the giving inertia to the system. They build up the grid inertia, and which is also again going to make the plants very stable during fault conditions. Particularly the fault is cleared in time because we have a source to feed the fault, clear the fault in time, and so that the STATCOMs, they work timely and they restore the voltage and the grid remains stable. So along with the synchronous condensers as we talk. So this is something. So these things we have to see that we, as we go along, we should not lose sight of adding the battery energy storage systems, the synchronous condensers wherever it is possible. So this is required to see that we have a plant which is efficient, which is without any issues, which works continuously, which takes care of the fault conditions, which is working even in the remote locations, because these plants, they will always come away from the main cities in the remote areas where we'll have issues of short circuit ratio, we'll have issues of inertia, and these things only can help us out. So these two things we have to see that we take care of the issues, the performance issues, the working issues by adding these things in a good measure. And that is what I can close with that.
Thank you so much for your thoughts. And now, lastly, I would like to come to you, Mr. Subrata Das.
It's a very interesting discussion, and I look forward, and future also we should have such discussions. My final conclusion will be in 4 points. Whatever we are discussing as a technical person, we are talking technical now. 4 points we should keep in our mind. One is whatever we decide, whatever we do, that should support Make in India. Number one. It means whatever power plant, I am talking about biomass power plant, that is 100% Make in India. Like this, whatever we do, that should be 100% Make in India. Next point is Swachh Bharat. Swachh Bharat means if you can reduce stubble burning, if you can make use of the agricultural waste and convert it into power, that itself is supporting Swachh Bharat. Third point is if such decentralized power generation is done in small scale and which is using local biomass fuel unprocessed, that will generate lot of manpower employment. There could be direct employment, that could be indirect employment, that could be consequential employment. So local people will get employment, and that too, especially for unskilled and semi-skilled person. And fourth point is farmers' income should be more. They should be able to sell that agricultural byproduct. So these 4 points we should keep in our mind whenever we decide something or implement something or whatever we do in our activity. These 4 points should be at the back of our mind. And with this, I want to conclude and thank all of you, sir, madams, and we look forward to similar interaction in future also.
Thank you so much, sir. Actually,
Most
this interaction and this talks, the expert talks actually means a lot for us, and it is informative, and it is going to be guidelines for everyone who wants to do something in this. And it is grateful for everyone. And I would, like to have this kind of conversation in future as well. So it could guide us in many, many ways. Thank you so much, everyone. Now, I would like to request Sachi to have to proceed with the closing remark. Thank you.
Thank you, panelists, for exchanging your valuable thoughts on today's topic, enhancing power plant performance. Before wrapping up today's session, we would like to thank our distinguished panelists, Mr. Baldev Raj Narang, Mr. Venkatesh R., Mr. Subrata Das. For viewers who have joined us today, we would like your feedback and encourage you to stay connected with us via our social media handles. EPR Magazine is now available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. We would also request our viewers to stay tuned for future interactions. With that, today's interaction has now come to a close. Thank you.